Okay, class, so today we are going to discuss the histogram. And to start our discussion, we are going to look at the definition and then we are going to construct one. So first let's start with the definition. So a histogram is a graph that consists of bars of equal width drawn adjacent to each other. And I want you to take notice of parenthetically how it says they're drawn without gaps. That without gaps is going to be important in a second. So these vertical bars are drawn without gaps adjacent to each other. And the horizontal scale, which is the x-axis represents classes. So if you have a graph, we know we have an x and a y-axis. The x-axis is going to represent the classes. And these classes have to be classes of quantitative data. And the y-axis, or the vertical scale, represents the frequencies. So we're going to have the frequencies on our y-axis, right? So the x-axis will represent the classes. The y-axis will represent the frequencies of those classes. So basically, the first class, which is this class that goes from 5 to 8, will be represented on the x-axis by numbering. The space between 5 and 8, there will be a vertical bar above it, and that vertical bar will go up to the height of the frequency of that class, which is 3. So the height of the bar corresponds to the frequency. Now, I want to draw your attention back to that without gaps part. Okay? Let's say we were to just draw or to mark off our class limits. These class limits from this first column of our frequency distribution. If we were just to draw our class limits, well, let's see. The first one will be 5, and then there's a space from 5 to 8, and the space above 5 to 8 is where we would draw a vertical bar with a height of 3 to represent the frequency of that class. Now, here's the problem. The next class begins at 9. So if I wanted to make a vertical bar to represent this class, it would have to be above the range from 9 to 12. So you see here the 9 to 12. And there's a problem there. Because if I create that vertical bar from 9 to 12, notice there's a gap. There's a gap between these two vertical bars. But if you remember in the definition, these vertical bars had to be made without gaps. So what I'm going to do is I'm going to have to figure out a way of closing this gap in here. See that gap in there? The gap between 8 and 9. How are we going to close the gap between 8 and 9? Well, what I have to do is I have to modify these class limits. What I'm going to want to do is I'm going to increase this upper class limit of 8 and decrease this lower class limit of 9 so that they're the same number. That way I'll eliminate the gap. And what I want to do that in a uniform way, so that what I'm going to end up doing is I'm going to add half of the distance of that gap to the 8. Well, the distance of the gap is 1 unit. Between 8 and 9 is 1 unit. So what I'm going to do is I'm going to take half of that 1 unit and I'm going to add it to the 8. So half of 1 is zero point 0.5. So I'm going to add 0.5 to the 8. And to modify the 9, I'm going to bring it back to where it should be by subtracting zero point 0.5 from it. So I'm going to take this 9 and I'm actually going to subtract zero point 0.5. Okay? So that's what I'm going to do. I'm going to take my upper class limits, which are these numbers on the right here, 8, 12, 16, 20, 24, 28, and I'm going to add zero point 0.5 to all of those. I'm going to add zero point 0.5 to all my upper class limits. And from the lower class limits, I'm going to subtract zero point 0.5. And those numbers are actually going to have a special name. The numbers that we get from adding zero point 0.5 to the upper class limits and subtracting zero point 0.5 from the lower class limits are called the class boundaries. So what I'm going to do next is I'm going to go ahead and I'm going to create all my class boundaries. So let's start off with the frequency distribution, and we're just going to modify all those class limits to make them into class boundaries. So I'm going to create basically a new frequency distribution, and in this frequency distribution, instead of class limits being the first column, I'm going to make the first column be my class boundaries. So over in the first column here, I'm going to put my class boundaries. All right. So notice that doing this does not change the frequency of any of the classes, because 8.5, there are no numbers between 8 and 9, so changing the class upper class limit to 8.5 won't affect any of the actual frequencies. So I'm still going to have my frequencies over here. And what I'm doing is I'm creating a frequency distribution that has class boundaries instead of limits. So from all my lower class limits, which are these numbers over here, from all of those lower class limits, I'm going to subtract zero point 0.5. So let's see, let's start with the first class. The lower class limit of the first class is 5. If I subtract 5 from zero point 0.5, I get 4.5. The next class, lower class limit is 9. If I subtract zero point 0.5 from 9, I get 8.5. And if I subtract zero point 0.5 from 13, I get 12.5. And I'm going to continue on in this fashion until I've done all my lower class limits and turn them into lower class boundaries. So the next one will be 16.5, and then the next one will be 20.5, 20.5. The next one will be 24.5. So there I've created all of my lower class boundaries. Now for my upper class boundaries. The upper class boundaries are the result of taking all my upper class limits, which are these over here, taking all my upper class limits and adding zero point 0.5 to them. So to the 8, I'm going to add zero point 0.5 to get 8.5 for my first upper class boundary. To the 12, I'm going to add zero point 0.5 to get 12.5, which is my second upper class boundary. And I'm going to continue in this fashion until I've done all the class boundaries. So the next one would be 16.5, and then we'll have 20.5, and then we'll have 24.5, and then we'll have 28.5. So what I've done is I've created class boundaries from my class limits. And like I said, the frequencies of the classes remain the same. So none of the frequencies will change. The class frequencies will remain the way they are. And from here, now that we have our class boundaries, we can actually create our histogram. So what I'm going to do is I'm going to go ahead and I'm just going to make a set, and I'm going to put my class boundaries in that set. So my first class boundary was 4.5. It's the lower class boundary of the first class. The next class boundary is 8.5. That's the upper class boundary for the first class, but it's also the lower class boundary for the second class. If you can see that there, it's the upper class boundary for the first class, but it's a lower class boundary for the second class. So what I've done is I've actually eliminated the gap. There's no gap between the classes anymore. The next one will be 12.5. I have the 12.5, and I'll have the 16.5, 16.5, make sure I get all these correct. Then I'll have the 20.5, 20.5. Then I'll have the 24.5, 24.5 here. And the last one is 28.5. So this set of numbers is what I'm going to put on my x-axis, the horizontal scale, to represent my classes. Now the y-axis is going to represent frequency. So let's see, I'm going to make my x and y axis here. There's my y-axis. Here's my x-axis. And what I'm going to do is I'm going to go ahead and mark off the y-axis with hash marks up to 5, because my highest frequency I see is 5. So 1, 2, 3, 4, 5. So this axis will represent frequency. The height of the bar will tell me what the frequency of that class is. So I'm going to make vertical bars, and let's see. Now my horizontal axis, I'm going to put my class boundaries. This set of class boundaries is basically going to be transposed onto my x-axis. So here I'm going to have 4.5 as my first class boundary, 8.5 is the next class boundary, 12.5 is the next one. And notice, not only are these equally spaced, so the bars will be of equal width, but there are no gaps between the classes. 16.5, 20.5, 24.5, and 28.5. So the space on the x-axis between 4.5 and 8.5 represents my first class. So I'm going to make a vertical bar above that class to represent the frequency. The frequency of my first class, if you'll remember, was 3. So I'm going to make a vertical bar 3 units tall to represent my first class. So here we go. Between 4.5 and 8.5, I make a vertical bar 3 units high. So that's all the information I have for my first class. It ranges between 4.5 and 8.5. Those are the numbers that would fit in this class. And there are three such numbers because the vertical scale, it goes all the way up to 3. Now for the next class, if you remember, the frequency of the next class was 4. So I'm going to make a vertical bar that extends all the way up to 4 on the y-axis to represent the frequency of that second class. And I'm making that vertical bar between 8.5 and 12.5, the class boundaries for the second class. So there I have a representation of my second class. Right, my third class, the frequency of the third class is the number 1. So I'm going to make a bar 1 unit high to represent my third class. And there's my bar of 1 unit. Now the next class is the largest class, the class with the highest frequency. Frequency of that class is 5. So I'm going to make a vertical bar above that class, ranging from 16.5 to 20. I'm going to make a vertical bar that extends all the way up to 5 on the y-axis, and is going to range between 16.5 and 20.5, the class boundaries of that fourth class, on the x-axis. And my last two frequencies are each 1. So I'm going to make a vertical bar 1 unit high for the fifth class, and a vertical bar 1 unit high for the sixth class. And there we have it. We have created our histogram. We have created a graph that has the classes of quantitative data on the horizontal or x-axis, and we have the frequency of those classes on the vertical axis or the y-axis. So by the very definition, this graph has no gaps. It is the histogram for our data set.